This video lecture is on the nervous system and the endocrine system and how they work independently of one another, as well as how they communicate with one another. So looking first at the nervous system, we have two different nervous systems in our body. We have our central nervous system, and I think about it as the center of our body. So you see it contains our brain and our spinal cord. So anything in the center of our body is controlled by the central nervous system. And then we have the peripheral nervous system, that is everything on the outside of the brain and the spinal cord. So I think about like our peripheral vision is the vision that we have out to the side. So central nervous system is center of our body. Peripheral nervous system is the peripheral vision. It's all of the outside of our brain and our spinal cord. So to start with the central nervous system, again, it contains two parts. It has the brain and it has the spinal cord. In the brain contains all the parts of our brain, which we are going to be getting into our next couple modules. But it also has what's called neural networks. So in our last video lecture, we talked about the role of neurons and how they are used to move those neurotransmitters throughout our body that communicate different things. And what neural networks are is they are strengthening of synaptic connections between different neurons. So for example, let's say that you are a violinist. The more you practice your violin, the stronger the neural connection is between the neurons that are used in order to play the violin. So I think about it as if we had like multiple dots on a board, and we took a black marker and we connected those dots every time we practice. We practice again, we go over it with a black line again. Practice again, go over that with a black line again. Imagining all those dots are different neurons. Well, the more times we practice, the thicker and the darker and the stronger that black line becomes, which stands for the fact that we strengthen these synaptic connections. We strengthen the connections between these neurons that are necessary to be able to play the violin, or to play lacrosse, or to throw a football, or whatever it is that you're doing. The more we practice, the thicker that black line becomes, and the stronger and the quicker and the better those neural connections are. And so those are what neural networks are. They're essentially a network of clusters of neurons in the brain that over time, as they are practiced and used, they become stronger. And so we want them to become stronger because then we become better at the things that we do. Then we also have our spinal cord, which contains something called interneurons. And these are a specialized type of neurons that are almost like, I don't know, a postal carrier, where those interneurons take information from the extremities or the peripheral nervous system, brings them to the spinal cord, and those interneurons then take those messages, send them up to the brain. Then they take messages from the brain, again, brings it down to the spinal cord via those interneurons, and those interneurons then send out messages to the peripheral. So it's just a specialized type of neuron that's just a messenger that takes things from the brain to the extremities and from the extremities to the brain. So that's the central nervous system. And again, in further modules, we're going to focus more on the brain and what are some of the parts and functions of the brain that operate as a part of this central nervous system. Then we have the peripheral nervous system, which is a little bit more complex. So to begin with, the peripheral nervous system contains two different kinds of neurons. So in the spinal cord, we have interneurons. In the peripheral nervous system, we have what are called motor and sensory neurons. And so motor neurons are neurons obviously for movement. Sensory neurons are neurons specific for touch or feeling. So our motor neurons would help us to move. Our sensory neurons would help us to feel. So those are the types of neurons that operate in our peripheral nervous system. If we also look at the peripheral nervous system, it's broken down into many different subsegments. I would, if it were me, I would copy this into your notes so that you have this visual. I think that that's really a helpful visual to understand the breakdown of the peripheral nervous system. So it's broken down into two major parts, the autonomic nervous system and the somatic nervous system. How I remember the difference between the two of these is I take the word auto out of autonomic, and the letter S out of somatic. And I think of the S in somatic like a stick shift car, and auto in autonomic like an automatic car. So the somatic nervous system is responsible for voluntary skeletal movements. So similar to a stick shift car, in a stick shift car, you have to move to the different gears to get things to move in the car. So the somatic nervous system is for movements of our body. So it's for our skeletal movements. Autonomic, in contrast to that, is like an automatic car. And an automatic car, without you even knowing it, changes gears. You don't have to do anything to get it to change gears. We have an autonomic nervous system in our body that automatically regulates and changes us. We're going to talk about that in just a second, but think about autonomic. Things happen automatically, such as our heart rate, our breathing, our dilation of our pupils, churning in our stomach, secretion of hormones. All of those things happen automatically in our body without our control over them. Versus somatic nervous system, like a stick shift car, is for voluntary movements like kicking a ball, throwing a ball, jump rope, those kinds of things. So back to the autonomic nervous system side, that is then broken down into two different subsections of that. There's what's called the sympathetic and the parasympathetic. And so sympathetic nervous system is in charge of arousal. And this is done by the autonomic nervous system, so we don't get to choose for this to happen. So when our sympathetic nervous system kicks in, it oftentimes kicks in when we have this fight or flight feeling, when we all of a sudden get scared or almost get in a car accident. All of a sudden, our sympathetic nervous system is going to jump into gear, and it's going to, without our permission, without our control, increase our heart rate. It's going to cause perspiration. It's going to dilate our pupils. It's going to put us into this fight or flight mode where we are just, our body is all of a sudden going into a panic. Once we realize that, say, that car accident was, you missed that car accident, or that really scary thing that happened, you're out of that scary, out of the woods for that particular situation, then jumps in our parasympathetic nervous system, which is in charge of calming us and bringing us back down into a resting state, which is where our goal is to be at all times. So I think about remembering the difference between these as I'm thinking about, if I have sympathy for somebody, I'm going to feel what they're feeling. I'm going to get aroused as they're getting aroused about something. And then I'm going to tell them, hey, let's pare it down a little bit. Let's bring it back down. Let's come out of our high. So that's how I remember the difference. Sympathetic is arousal. I'm going to feel what that person who's upset is feeling. And then I'm going to tell them to pare it down, bring it back down, calm yourself down. And that's where the parasympathetic nervous system comes in. This is a great chart from your book. Again, something I might write down as the differences between the automatic functions that the sympathetic nervous system does versus the parasympathetic. So when we look at our pupils, in our sympathetic, when we're aroused, our pupils are going to dilate. Our heartbeat is going to accelerate. We are not going to be able to digest. We are going to have a relaxing bladder, where we might, when you get really nervous before, say, you do a performance, you might feel like you have to go to the bathroom because your bladder is relaxing. In contrast, we have the parasympathetic nervous system, that when that comes in and it calms us down, it contracts our pupils back to normal. It slows our heartbeat back to a resting heartbeat. It stimulates and allows us to digest. It contracts our bladder and allows us to be able to hold our urine. So when we look at these things, think about somebody who gets ulcers because they're so anxious. Well, what's happening is when you're really anxious, your sympathetic nervous system is constantly aroused. Well, that's going to inhibit your digestion, because you can't digest food when you're really anxious or on edge or you're aroused. And so that might cause you to start getting stomach aches, might cause you to start getting ulcers, because your body is not able to function at its highest potential if you never are calm, if your body is never in a resting, normal state. So that's where those two systems have to work together. We don't want to be aroused all the time because that can have negative effects on us, but we also need to be aroused at times in order to be cognizant of what's happening in our environment. So these things happen automatically. We can't control our pupils dilating. We can't control our digestion. We can't control our heartbeat. These things all happen automatically via the autonomic nervous system. Okay, so making sure that we know the difference between the sympathetic and parasympathetic and what it does in our body would be really important. So writing down those couple differences, I think, would be really helpful in your notes. All right. Tied in with this is the endocrine system. So tied in with this autonomic nervous system, this automatic function, not only does it break down into the fight or flight of the sympathetic and the calming of the parasympathetic, but it also helps to regulate our endocrine system. And our endocrine system is the system in our body that secretes hormones into the bloodstream that do different things. So two particular parts of the endocrine system are the adrenal glands, and the other one is the pituitary glands, both of which are regulated by the autonomic nervous system, and both of which secrete hormones into our bloodstream to allow for different things. For example, our adrenal gland is located on the top of our kidneys, and this releases epinephrine or adrenaline to arouse the body in times of stress. Or how you might connect to this is an EpiPen. EpiPens are given to individuals who have severe allergic reactions in order to give their body a quick shot of adrenaline in order to counteract the allergic effects that they are having on their body. So the adrenal gland automatically secretes this epinephrine into our body when that sympathetic nervous system goes into that fight or flight. It's automatically going to connect to the endocrine system, talk to the adrenal glands, and they're going to send out that epinephrine that's going to help arouse you and increase that heart rate and do all those things that the sympathetic nervous system does. Another part of our endocrine system is our pituitary gland. And our pituitary gland is located in the brain near the hypothalamus, and you're going to learn about the hypothalamus in further modules. But the pituitary glands are responsible for releasing a growth hormone to allow you to get bigger, to grow taller. I remember this one by looking at the pit of an apple. The pit of the apple usually has the seeds that allow the apple to grow. So if you remember, pituitary gland is like the pit of an apple. It's the seeds that release a hormone that allow us to be able to grow. So that is it for this video lecture. Again, if you've got questions or concerns, shoot me an email.